Hello everyone, welcome to the Polkadot Club Introduction to Substrate session. Today we're going to have Han Ying, the Phala Network Chief Scientist, who's going to be giving the presentation today. If you haven't already, be sure to come along to these sessions live, and you can find all the information in our Discord and Eventbrite. But over to you, Han.
Okay, thank you very much, George. Let me share my screen. And at the same time, I think it's good to just share the link to the slide so people can just use it. Let me share my screen. Is it okay? All right, hello everyone. I'm Han and I'm from Phala Network. So today I'm very glad to be invited here to participate to give a presentation about intro to Substrate. And this is a part of Encode Polkadot Club series. So I'm the co-founder and also the lead developer of Phala Network. So today we're going to talk about Substrate for sure. So there we will separate this event for three parts. The first is what is Substrate, and then the basics of Substrate, and the third session will be a bit longer, which is a live coding session. I will show you how to build a simple blockchain with Substrate. Yeah, so I think before we start, I assume that most of the people in this events already have some basic understanding of what is blockchain, or at least have some basic understanding of the smart contracts. If not, maybe you need to read more after these events, but I will not put a lot of basics in this presentation. Yeah, so before start, let me give you a brief introduction of who are we. So we are Phala Network, and as some of you may know, we are a part of the Polkadot ecosystem, and we see us as the new generation Web3 cloud. So it's basically a permissionless cloud computing infrastructure based on Substrate. So it's naturally to think about why we need to use Substrate. And as you know, there are plenty of sharing economic business around the world, but we want to build something different that is permissionless and a sharing economic for cloud computing. And that's why we want to make sure there is a permissionless network, allow anyone to join the network, to contribute their computing resource to the network. And then we need something to organize this network. That's why we need a blockchain. And just give you some background. So we have two blockchains. One is Kala, another is Phala. And Kala is the first parachain on Kusama, and Phala will we will try to become a parachain on Polkadot because it's still not launched yet. All right, so that's all the background. Let's talk about what is Substrate. So when we are talking about decentralized app or decentralized decentralized network, then probably there are two words come out of your mind. One is the smart contract, another is blockchain. So smart contract, I think, is more easy to, it's more common to use and easier to interact. It's basically just a tiny piece of code on the blockchain. You can interact with the code. You can invoke it by sending some transactions, and you can read the data saved on the blockchain and maintained by that piece of code. And whenever you think about how to deploy some application on blockchain, there are a few pros for smart contract. The first one is serverless. So you don't need to really need to spend some efforts to maintain a full network, unlike a full blockchain. For example, if you are going to build a smart contract and deploy on Ethereum, the only thing you need to do is to learn how to write Solidity language. It's a JavaScript-like language, and then you can compile it as a bytecode and deploy it on Ethereum, and that's how it will be running on Ethereum forever, and no one can stop that, and it will only execute as how you write the code. So that is the so it means that if you deploy some smart contract, it's really easy to write and really easy to deploy. And after the deployment, you don't need to spend any effort to maintain that. However, the smart contract also has some drawbacks. For example, smart contracts are slow. Like on Ethereum, the average TPS, which is transaction per second, is around 15. So it means that if you put some application on the blockchain and you have maybe millions of users will have some very long delay every time when they want to interact with your smart contract. It's slow. And it's also expensive. And the reason of expensive, I think, is also kind of related to the reason why the smart contracts are slow. Because on Ethereum or any kinds of smart contract blockchains, no matter how many servers or how many nodes running in the network, the capacity of running the smart contract doesn't change at all. And it may even decrease a little bit, because when the network grow larger and larger, then it will make the consensus slow down a little bit. And because the overall capacity is limited, so everyone deploy their own smart contract on the same blockchain, and it will create a kind of some like a traffic jam. Everyone wants to run their smart contract, but there's limited TPS. And if you if you have checked with the gas fee on Ethereum before, you will see that at some point the transaction fee is really expensive. Like you make a simple transferring, maybe it can take around $33 for just a single transaction. And on the right side, that's a screen shot of gasnode.org. You can check that. Now it's not that expensive, but it's still something. So it has limited resources, means that you cannot put a lot of computing extensive things happening on the blockchain. The same time, you cannot put a large amount of the data on the blockchain. For example, like for Filecoin or Arweave, this kind of storage blockchain, you need to store a lot of files. And on Ethereum, usually you just store some account data or balances. So that's why this DeFi infrastructure can run smoothly on Ethereum. But if you want to store like an image or some file on a blockchain, then it will be really expensive. And the same time, Polkadot, if you have some knowledge before, Polkadot is a network of blockchains. It doesn't only offer the functionalities for a single blockchain, but it builds the bridges between the different blockchains. So it means that they need to have some customized consensus, some very complex mechanism to make sure the transaction between the transactions, between the blockchains are safe. So it has to be, it requires the blockchain itself to be very customized. So it cannot run as a smart contract. And the Phala network is a network of computing resources. And for the same reason, it's very hard to put it just in a smart contract. So what about a blockchain? If we are going to build a blockchain, then everything is different. You can build everything to fit your needs. For example, you can build a blockchain to just deal with the storage. You can build a blockchain to bridge the different blockchains together. But if you want to build a blockchain, do you really want to build it from scratch? Then you need to build the P2P network, because it's a network of P2P nodes. They need to connect with each other. And you need a database, right? You need to store some on the blockchain. For example, for Bitcoin, that is the balances. For Ethereum, Polkadot, that is the account data on the blockchain. You need to deploy your own consensus algorithm to make sure the database in a decentralized network is well synchronized. And you also need a sandbox to run the smart contract. And you need the smart contract programming model, the SDK, and all the rest, like the front end, the governance model, the staking model, and the multi-sig model, and all of your the business logic. So that are a lot of things to do. And actually, as a developer, I think we would rather to just focus on the things we want to build rather than this very low level infrastructure things. So what we need is a framework. We need a framework to abstract all these low level things together. And we want a tool to just start building our own things on top of that. So that is our subject today, the parity substrate framework. So in the second section, we're going to talk about the basics of substrate. And just like what I have shown you before, there are a few, like a bunch of different modules, and we need to put them together and make a fully working blockchain. And the good news is that Substrate have already done that for all the developers. So this is a very brief overview of a Substrate client. It has the P2P networking model built in the client. So you start the client, and this client can find each other automatically and maintain the connection for the entire network. It has the RPC module, so you can interact with the node. It has the consensus module to make sure all the data or the database among this network is synchronized and be consistent. And there is a storage, and there's one thing very special, that is the WASM runtime. WASM is just a web assembly, which is just the standards of some virtual machine not dependent on any special CPU or platform. And what Substrate did is that it puts all the blockchain specific logic, including your business logic, how your blockchain is defined, like what is the format of your block, what is the format of your block header, or the transactions, or all this data, how it's stored in the storage. It's already defined within the WASM runtime. So it means that the WASM runtime itself is hot swappable, and it can interact with all the infrastructure provided by Substrate client. So put them together, Substrate is a ready to hack framework. It has a very well-defined modular design. So every module can be changed as you want, and it's highly customized. For example, on Polkadot, it has a very customized consensus to interact with the parachains. But maybe you can also use Substrate to build your own standalone blockchain. It can be very simple. You can also use Substrate to build your own private blockchain. It may even doesn't have any token on top of that. And it also supports forkless upgrade thanks to the WASM runtime.
Sorry, Han, we just had a couple people in the chat asking if you could put these slides on full screen mode. That would be all right.
Okay, sure.
Thank you very much. Apologies to interrupt there.
Okay. All right. So yeah.
I think yeah, that's perfect. Cheers. Sorry.
Okay, no problem, no problem. So let's take a closer look at what is inside the WASM runtime. So here, these two pictures are from the Substrate official website. So as you can see, there are two things. One is the runtime, and another is the frame palettes. So the term frame and palettes are just the term in Substrate world. It means the business logic organized by a few modules, and these modules can be configured. So it offers a toolkit of some commonly used module. For example, like assets. It defines a module that can handle multiple assets. It can be created by the users, and it supports the transferring or some other basic stuff. And another example is the EVM. EVM is also a module in Substrate. So basically, if you put an EVM module in Substrate, then you can deploy Solidity-based smart contract in your own blockchain. Or like there are also multi-sig, pseudo, utility, these different kinds of palettes. These are already developed by Parity, and and you can pick the one you want to use and just plug them together to the runtime, and then that is your own blockchain. So how to build on Substrate? So I think the first thing you need to you need to take care is that almost all the code write for Substrate is written in Rust, and Rust is a pretty new language, and is statically compiled, and it's very safe. It can make sure as long as you don't use the unsafe feature, it's always memory safe. And also it's very high performance. So because it's very safe and it offers high performance, so it means that it's very useful to develop a blockchain. Because for blockchain, we really cannot put a lot of computation introduce a lot of computation overhead on the blockchain. So performance is very important for blockchain. And on blockchain, we usually run some very critical tasks. For example, dealing with the financial stuff. So we want to make sure on the language style to make the logic as safe as possible. And that are the good part Rust can offer. But Rust itself has some very it's a bit hard to learn, but it's not too hard. So I think it's still worth learning. And the second step, when you are familiar with Rust, we can start with a template. So just under Substrate Developer Hub, there is a repo called Substrate Node Template. It's basically just a template for Substrate, and you can download it, compile it, and that is already a very simple blockchain, and you can make your change on top of that. And the third step is to build your own palette. So palette is just a module for your own business logic. You can have one palette for your stuff, and you can also define a few palettes and let them to interact with each other. You can also interact with the existing palettes offered by Substrate itself. And the fourth step, you can launch the blockchain and connect the front end to your blockchain. And here is a screenshot. You can see this is the Polkadot.js front end connected to a Polkadot node. And the front end itself is just a static web page. So of course you can connect to the official nodes operated by Parity or some other organization, but you can also run your own node. So this is fully decentralized. It doesn't rely on any centralized organization. Okay, so that is just the basic steps to build on Substrate. And before we dive into the live coding session, I would like to show you who are using Substrate. And among all of them, I think there are at least 100 teams building on Substrate. And maybe now it's much more than that. But among them, the most famous is Polkadot and the Canary network, Kusama. So let me show you how it look like. So here we have a running Polkadot JS frontend. Let me make it larger. And as you can see, this is the default page. And you can see a block explorer. And you can see there are blocks being produced every 6 seconds, which is just the default block interval. And on the right side, you can see the events happening on the blockchain. So this is Polkadot. And as a blockchain, of course, there are accounts. So here I'm showing you the accounts, and you can see there are plenty of accounts injected by the Polkadot extension here. You can see the balance here, and you can send some transaction like from one account to another account. You can specify some amount to send, right? But these are the very basic stuff for blockchain. You can also see other things. For example, staking. So staking is a module offered by Polkadot, and you can stake for some validators, and you can earn some money. If you run some validator, you can also stake for the other validators. And there are governance module, and democracy basically means that anyone on the blockchain can make a proposal, for example, change some parameters on the blockchain, or even do a blockchain code upgrade. And people can vote for the proposal. And if the proposal is passed, then an on-chain action will be performed to just do something with some very high permission. For example, like upgrading the runtime code. And yeah, all the token holders can vote on the blockchain. And here is another menu called developer. And this is very useful when we are developing the substrate-based blockchain. And on chain state, you can read the data on the blockchain. And under extrinsics, you can interact with blockchain. And in the next session, we're going to use these functions.
So we just have a few questions from the chat. Would you like to take them now? There's only about 4.
I'm sorry?
We've had a few questions from the people in the audience. Do you want me to read them out for you?
Okay, sure.
Sure. So Kevin asked, what are the best use cases to start building Substrate dApps?
I think Substrate itself is highly abstract. So it means that you don't really there's no single use case Substrate build for some single use cases. So like for example, I think there are DeFi projects like Phala built on Substrate. They can offer a fully featured DeFi infrastructure, the functionalities. And there are also some storage blockchain like Trust. They are building a blockchain a bit like Filecoin, but with some different technologies. And of course, for Polkadot itself, it is the relay chain, the chain to connect the different blockchains together. And it can make sure the network of blockchains can communicate and interact with each other. So, so my answer is that I don't think there's really any specific use case just for Substrate. I think any innovation can be supported by Substrate. It's really easy to use and highly customized.
Awesome. Thank you very much. And then Eric's asked regarding Rust, why do I need memory safety?
Yeah, that's a good question. So there are a lot of problems or bugs found from the very critical projects, for example, the Linux kernel, or even like the Bitcoin client. And among all these bugs, I think at least 1/3 of them are created are due to the memory safety. For example, they are using the memory in a wrong way. So there are maybe some leakage or some memory overflow problem, and there are maybe some risk condition, and all of them can be prevented by Rust. So I think it can really make the project more stronger.
Awesome. And Julian asked, is state size limited?
State size is not, well, if you have to ask, I think it has some limitation, but unlike Ethereum, I think for Substrate, the limitation is much larger. I mean, it has a much higher limitation. So it means that as long as your machine can have enough RAM, enough disk, and it can have almost unlimited amount of the storage. I mean, the on-chain state is also called storage on Substrate side. But of course, to make sure your blockchain can run with the best performance, you still need to limit the state to make sure less as much as less as possible to use. So it's just the best practice. But I think in terms of the limitation, Substrate is much better.
Fantastic. And John has asked, can I create an app that connects to my Substrate node running on either Polkadot or Kusama?
Of course, you can be a parachain, and the parachain can connect to Polkadot or Kusama, and then you can interact with Polkadot or Kusama.
Awesome. And Julian said, can you discuss how bridges will operate or cross-chain dexes without using collateral?
That's a very in-depth question. So I think let me give you a very brief answer, and maybe you can search for more. We can discuss after this event, or you can search for more materials later. So basically, Polkadot offers something called shared security. So it means that in theory, we can put some module deployed on multiple blockchain, multiple parachains connected to Polkadot, and all these parachains, this module share the same code, and Polkadot can make sure all the code run, all the storage used by this module is maintained by this module itself. It cannot be like manipulated by some other palettes or other the rest of your the rest part of your blockchain. So they call this Spree, SPREE, which is a really advanced feature. And you can already see something. It's not fully implemented, but you can already see some sample on Polkadot. Now you can do something called teleport between between Kusama and StateMine, and maybe I can also show you that it can be very quick. So teleport means that you just reduce some amount on one blockchain and add some amount on the another blockchain, and it doesn't require any collateral because the code itself is guaranteed to be safe by Polkadot. So that is the shared security. So as you can see, here is the teleport. You can just burn some token on the Kusama and get the same amount on StateMine. That is a parachain. But it's still a feature in development. So maybe it need another few months to be alive.
Awesome. I think that's all the questions for now. We'll definitely get to some more at the end. Thank you very much.
Okay. Okay, cool. So yeah, we have already finished the first part, and yeah, the only thing left in this part is oh, sorry, click to the run button. All right. So let's say now we know Polkadot Kusama are using Polkadot to build their blockchain, and and for us, Phala Network also is also built on Polkadot. So like on the left side, you know, there is the Ethereum. It's just a single blockchain, and the Polkadot may have 100 parachains, and on our end we may have like maybe thousands or even 10,000 of off-chain workers running to do the computation. So that's how we use Substrate to organize our network. Okay, so the next session is to build an actual blockchain. Yeah, so for this part, we have built a simple, very simple blockchain, which is just a forum. And there's only a single function, is to post post a thread on the blockchain. So a poster should have at least a title, some contents, and also it has the there's the author of the post, right? So we're going to start from the Substrate node template, and to turn it into a simple blockchain that can post some messages like a forum. So to build the blockchain, we need to install Rust, and that's not part of this demo. And we're going to start from the node template. And here's the command to just clone a node template from Substrate Developer Hub. But just to save some time, we have already cloned the code here. So like now we have a clean Substrate node template, and it's very simple to just start that. Just run it as a regular Rust project. So cargo build release, and if you build it from scratch, it may maybe 10 minutes or even 20 minutes, because it takes some time to download the block, download the dependencies, and compile all the codes. But we have already pre-compiled that, so it already finished. Let me run that. The compiled result lives here. So under target, release, and we have a binary called node template. Let's just run that. So release, target release, node template. And we give two parameters. One is -- temp, another is -- temp means that now we just start a temporary blockchain. It will not save on the disk. And dev means that this is just a single node running locally for development. And now if you check the output, it's already producing the blocks, right? So the next step is that we can connect, we can attach the Polkadot.js user interface to the node we just started. It's very simple. We connect to Polkadot.js, and then we connect to the local node. So by default, the port is listening to 9944. So let's switch to that. Yeah, it's locally, so it's very quick. And now we already got the first blockchain running. This is the this is the block 10, and every 6 seconds a new block is being produced. And we have the accounts, right? So we have Alice, Bob, Charlie, and they are all the development accounts offered by the development mode automatically. And it already have some token in the account. So for example, like we can transfer some token from Alice to Dave. Like we can transfer 1,000 token. It's sending the transaction. And yeah, it's already in the block. And as you can see, so Dave now have 1,000 unit token. So that's just a transaction. Now we already have a running blockchain, and let's check what is inside this blockchain. So as I have mentioned, this is a node template. So it's basically just nothing but just a template. But there's still a module here. A model here is the template model, and it has a function called do something. So now we are under the developer extrinsic, so it allows us to send any kinds of transaction to invoke some functions on the blockchain. Let's just put some data on the blockchain. We put 1, 2, 3, 4, and send a transaction, do something, and then we can read the database from chain state. And here it is, template module something, and here we go. Yeah, 1, 2, 3, 4. That's the number we just put by sending a transaction. And if we check the code, the code structure is it's not super clean, but we just basically take care of two parts. One is the runtime. The runtime defines the blockchain itself, and another is the palette. So there's only one palette called template, and that is the module we just interacted on the front end. And the function we called was do something, and it was defined here. And it basically just accept an unsigned int called something, and save it in the storage. And the storage is defined here. The name is something, and the type is the U32, right? It's very simple. So what we're going to do is to make some change and turn it into a forum blockchain. So to save some time, let me just, sorry, I think before that, I would also like to mention the last time we ran with temporary, this command line flag, so it will not save any data on your local machine. But if we specify /d, and then we can specify any directory, for example, TMP and block and maybe chain1. And def, we start a blockchain. This time it starts from scratch, but and we can also see this blockchain running, right? This is just the first block, the second block. And if we stop that, and now the front end get disconnected, but we can still resume the execution of the blockchain from the point we just stopped. Like this time, it's not from started from 0, but from block 3. So in this way, you can run some development blockchain locally, and don't need to fear the loss of data. All right, and yeah, let's make some change on the existing blockchain and upgrade to a forum blockchain. So to save some time, we have already changed the code. So let me just check out. So upgrade workshop finished one. All right. So we have already changed the code, but no worry, it's just a very tiny amount of the code. So let's go through them one by one. So first of all, we are going to develop a forum blockchain. So we need to store some posts on the blockchain. So the first thing we are going to do is to define a structure called post here. So even if you don't know how to read Rust, but I think it's still very simple to understand. So here is the struct called post. It has three fields. One is title and content and author. And for title and content, they are all bytes. So you can put any string as the title or content. And the author is an account ID. So this is the first step. The second step is that we need to store the posts on the blockchain. So we define two storage items. So the first is the post. Post is a storage map. So it's a map on the blockchain. The key of the map is an ID. The ID is a U32. It's just the unsigned int. And the value is the post. So you can safely ignore this Rust related stuff for now. And so in this way, we define a storage item called post, which map from the post ID to the post itself. And then we also define another storage item called next post, because maybe the first post we are going to just name it the post 0. The next is post 1 and post 2, 3, 4, and like that. So we want to know what is the ID of the next post in this blockchain. So the next step is we define two storage items. And the third step, we have removed all the existing functions from the node template, and we changed that to a single function called post. So the post can be invoked by sending a transaction to the blockchain. And it accepts two parameters. One is the title, another is the content. And by sending a transaction to the blockchain, the transaction itself must come from some wallets, right? So the wallet itself is identified by the parameter called, the argument called origin. So we can get the address of the sender from this argument. So the first thing we do is to call a function called ensure sign to make sure this transaction is signed by some wallet, and we get the address of the sender. And the next step, we read the ID of the next post. So we basically read it from the storage, and if it doesn't have anything stored on the blockchain, we give a default value of 0 as the post ID. And the next step, we create a new post here. So the code I have selected is to construct a struct called post with the title specified from by the transaction, content also specified by the transaction, and the author is the sender of this transaction. And then we just insert it into the blockchain. And finally, we update the next post. So here we just increment the post ID by 1 and put it back to the storage. So that's all. We just use a function to store something on the blockchain. And let me compile that. So this time it will take some time because we have made some change in the code. And usually if you compile a blockchain, a substrate-based blockchain from scratch, it can easily cost you maybe 20 minutes to build it. But my suggestion is that maybe you can get a powerful CPU, not necessary to have a very high RAM. So on in my work environment, I have a CPU with 30 it was 28 cores. It was an Xeon CPU, and it is much better than just some virtual machine you grab from the cloud, like 1 core or 2 core. It will be easy to take maybe 1 hour to compile a blockchain. But after the first compilation, the rest, if you make some change, that's just the incremental build, so it will be much faster. Yeah. Although I did mention, if we build this new blockchain and we delete the existing blockchain database and start a new one, and we can expect the new blockchain is running. But Substrate itself offers a very good feature called runtime upgrade. It means that you don't really need to kill a blockchain or hard fork a blockchain to perform any upgrade. The upgrade can be performed on the blockchain without any fork. And like if I want to make some change on the blockchain, what I should do is to prepare the code, upload it to the blockchain, and then I can create a vote on the blockchain. If there are sufficient votes to vote for this blockchain upgrading proposal, then the blockchain can be upgraded. If not, then it will be discarded. So this is the best way to enable continuous upgrading on the blockchain and let the blockchain evolution itself to be decentralized. So it's already finished. Let's run. Oh, yeah, let's run that. Target release template, node template, and we continue with the blockchain database we created before, and the that single D. Okay, it's running. Let's check if this is a new blockchain or an old blockchain. So it's showing imported 8. So it doesn't start from 0, but from 8. And if we check the front end, it automatically connects to the node. And now we are still the node template 100. And if we check the chain state, this is a template module. It's still, it is still the old blockchain we are seeing. But now, how can we apply the new runtime on the blockchain? There's one thing missing. Sorry for that. To make the blockchain upgradable, beyond changing the code itself, we still need to change the version. So on Substrate, there are 2 versions. One is the spec version, and another is the implement version. And if you read the comment here, it says that if you make any change of the blockchain behavior itself, for example, add a new function, or remove a function, or change the behavior of some function, you have to increment the spec version to make sure the substrate can know now it's already a new version of the runtime rather than the old version. But for the implement version, maybe you, if you just make some optimization or clean some code cleanup or refactoring of the code, but it doesn't change the logic of the blockchain, then you can increment the implement version here. So don't forget to increment version, the spec version anytime if you make the change to the code. All right, it's still compiling, but this time, instead of just running a new node, it's not enough. We need to get the wasm code of the runtime and do a runtime upgrade. So the wasm code is under target release wbuild node template runtime. And let me make it bigger. Here you can see there are 3 wasm files, and they are all node template runtime. That is the runtime file, including all the logic and the definition of your blockchain. And there are 3 files. One is the original file, another is compact, and another is compact compressed. And of course, the first one is the minimized one. And they are all the same. So we can choose anyone. And usually we use the compressed one to run to do the runtime upgrade. And while it's still building, I can show you something interesting as well. So here is the substrate.dev. This is the developer hub, and you can find a lot of useful information on this website. For example, you can find the tutorials. You follow the tutorial and learn the different parts of Substrate. And you can check the knowledge database, that is the documentation about Substrate. All right, it's already finished. Let's do an on-chain upgrade. So let's start the blockchain first. We still start the old blockchain, right? It's not the new blockchain, although it's already compiled with the new code, but it's still the old blockchain. And it's on the block 20, right? And then we download this code. Let me download this code to somewhere here. And this time is the V101. Let's save that. Let me start, create a new window, documents. All right, so here is the node template runtime I just compiled and download to the local computer. And then we can do an on runtime upgrade. So to do an upgrade, we need to use the pseudo permission. And usually on a live blockchain, you will not find the pseudo palette, because this is basically prepared for the development. And if you run a fully decentralized network, you shouldn't use that. And under system palette, there is a function called set code. So it can be used to upgrade the code. And I can choose a file here. Let me just drag it. All right. So we have a new runtime code, and I can give it just a random weight to make sure it doesn't hit the block limitation. And then send a transaction. And yeah. And here, just after 6 seconds, it shows suited, means that the transaction is executed successfully. And if we check the details of this block, you can see system.code updated. And on the right top corner, this time it's showing node template 101. It's already upgraded. But after each upgrade, it's best to refresh this page to make sure it can load all the latest metadata. It's still called a template module, but if we check the storage, now instead of something we saw in the past, now we have next post and post U32. Of course, there's no post now. Let's create some post. We can use any account like Alice, and we call template module post. I can create some title. Substrate workshop. Hello, substrate. Let me just create a transaction with some title and some content. And we submit the transaction to the blockchain. And here we go. Let's check the chain state. Template module posts. The first post, the ID is 0. So we can use 0 as the key to get, oh, one more thing missing here. So as we have defined the new structure, but the front end itself doesn't know how to read the data from the blockchain, especially how the data is serialized. So there's one more thing we have to do. We need to define how this structure can be decoded in the front end. So here we use settings, and in developer this page, and we just paste the definition of the post structure here. So it's just identical to what we have written in the code. It has 3 fields: title, content, and the author. And the first 2 fields are all string, and the third one is the account ID. And let's save that. Now we can try to read the post. Not this one. Okay, here we go. So this is the post 0, and it has the title, Substrate Workshop. It has the content, hello Substrate, and it also has the author. And this one, you can check, this is the Substrate format, the wallet address. And if I send another transaction, maybe this time from Bob, and in the chain state, we can see there are 2 posts, right? The first one is the post 0 from Alice, and the second one is from Bob, and they have different addresses. And we can also verify this address is the one of the sender. Let me create a new window. So this one is the shoot from Bob, right? So here we can check, this is the account of Bob, and if we click this, and we can see the account of Bob, and they should match. Yeah, that's true. All right, so here we just finished the live coding. So what do we have shown in this live coding session? The first is how to define the storage items, and then how to write a function to save some post on the blockchain. And the things we haven't covered, but it's still part of the palettes, is the arrows, the events, and you can also define the APIs for people to retrieve some data from the blockchain. You can also define some hooks, and hook is something if you write maybe some smart contract, it cannot offer for you. For example, you can define a hook to execute some logic at every block. And on Ethereum, all the transaction needs to, all the execution must be initiated from a transaction. Yeah. And this is the link of the front end. So it's Polkadot.js, and it can be used to connect to any Substrate blockchain. Yeah. So what about the next steps? And we have a lot of resources. You can check out substrate.dev, and there are docs, tutorial, and the references. You can get like all the definition of the types, the structures in Substrate from the reference. And you can also check the recipes. It has some very interesting use case or some more advanced topic discussed here. It can help you to get more advanced knowledge of Substrate. And we also have a link here. So if you are interested, you can check the full instructions of this workshop. And actually today we just showed the first part of the full workshop. The full workshop is about the runtime upgrade, storage migration, and you can even test a deployment of the new runtime before do that on a live blockchain. You can fork a blockchain locally to test it out. Yeah. All right. So yeah, that's all. So thanks for everyone to listen. So if you are interested to learn more about Substrate, feel free to join the official Substrate technical group. You can also send email to us to ask questions or discuss some other blockchain related stuff with us. And if you find it out, in the left bottom corner, we have a hiring link. So if you are interested, feel free to check it out. We are hiring the blockchain advocates and the blockchain developers. Yeah, so that's all from my part.
That's fantastic, Hang. Thank you so much. That was an amazing presentation. We have a few questions from the chat. I don't know if you have time to take a few of them quickly.
Sure, no problem.
Sure. Okay. So Eric's asked, can I run on Polkadot even if I don't get a slot as a full parachain?
Yeah, this is a good question. So from the beginning, Polkadot is designed for only maybe around 100 parachains. But just in 2 years ago, there's a new concept called parathread. So for parathread, it's like threading or process in an operating system. It's a time sharing mechanism. So on Polkadot, there could be 100 parachain slots, and maybe 1/3 of the parachain slot will be reserved for parathreads. So now, from the information I have, in my understanding is that each parachain slot can be shared for up to 10 parathreads. And if you have some transaction pending, and you can pay some transaction fee to be upgraded as a parathread and run your transaction. And if there's no transaction, you just swap out and leave it there, waiting for the new transactions coming. So in this way, it's kind of like a balance between the fully owned parachain, which means this parachain slot is only for a single blockchain. And on the other hand, like Ethereum is a fully preemptive, a preemptive module. You can deploy any smart contract, and as long as you pay enough transaction fee, your transaction can be executed. So parathread is a position between these two model, right? You can still start a parachain, but it is a parathread and it is pay as you go fee module. Yeah.
Fantastic. And there's been a few quite different questions which I'll maybe kind of collate into one, but basically, as a web developer or kind of existing developer that wants to get involved in Polkadot's ecosystem, what would be the kind of first steps that you'd recommend, particularly for someone that doesn't perhaps know Rust?
Is this question mean if like for new developer, what is the first thing to start learning or start building?
I think for people who are existing developers but maybe don't know Rust or Substrate at the moment.
Okay. I think there are a few use cases for Substrate. One is to, of course, to build the parachain. And if like you want to build a parachain, I think 99% of the case you have to use Substrate. And now we have like a Phala, the DeFi parachain, and we have a Moonbeam, the EVM compatible parachain. And you can also build your own parachain, like maybe a file storage parachain or some bridges, right? So I think these are the things is very suitable for Substrate. And you can also use Substrate to build standalone blockchains. And we know plenty, a bunch of team building standalone blockchains. It can even be not connected with Polkadot at all. And at the same time, you can use Substrate to build some maybe some consortium blockchain as well. So my suggestion is that if you think you really need to build a blockchain, and of course it means that you need to put more efforts. For example, you need besides the development, you also need to maintain a full blockchain and the network and a lot of different stuff. You need to develop your own maybe blockchain explorer and connect to the wallets. But it also means it's very flexible, right? So you really need to build a blockchain. Then you can start with building some standalone blockchain, and then Polkadot offer a library called Cumulus, and just maybe within just a few days, you can turn your standalone blockchain to a fully featured parachain, and it can be ready to connect to Polkadot. So this is the suggestion for blockchain builders. But at the same time, if like you just want to build some small use cases, you don't really need to build a fully featured blockchain. You can have a try with maybe steal Solidity and deploy on existing EVM compatible parachains like Moonbeam, or maybe in the future, Phala Network will also support EVM. And there's also another interesting smart contract language called Ink. I think maybe EVM is already well adopted by a large community, but Ink is the next generation smart contract. And by using Ink, you can use all the libraries available in the Rust ecosystem, and you can build much more complex and computation extensive smart contract with Ink, and deploy on Polkadot on Polkadot parachains natively. And that is it will be supported by most of the parachains in my understanding. And on our end, the Phala Network will also support Ink deployment. So yeah, I think that are the two directions as a good start point.
Fantastic. We also have a question from Skylar who asks, how does identity work on Polkadot?
Good question. I think I can just show you something on Polkadot. So by identity, I think what you mean is not just the wallet, because for wallets, that is everywhere. Bitcoin and Ethereum all have the wallets. But on Polkadot, there is actually a palette called the identity. So here you can see the name is identity, and it offers plenty of functions. But basically, in the accounts page, for any account, like these accounts are just these accounts are just the regular accounts without any identity. And for this one, as you can see, there is a green check before the name, right? So for any account in this page, there is a function called set on-chain identity. And you can give it a name. For example, like I'm maybe Alice, and you can set a few fields like legal name, maybe Alice, and Alice at example.com. You can also give it maybe website, Twitter, route handle, and then you can set send a transaction to the blockchain. But this identity doesn't mean you can set anything as you want. After you send the transaction, it will reserve some money to make sure you don't abuse these functions. And then you will require some people who are registry to verify your identity offline. So now it works in this way. There are, I don't know the number, but at least there are two registries. You can reach out to the registry, and they will make sure you own the email. Maybe you send an email with a signature of your account to the email of the registry. And they may also manually check your website, your Twitter account, route name, manually or automatically. And then after all the check, like in this account, this is not verified, so it shows a gray icon in front of my name. But for this account, there's a green check, means that this identity is already verified by some registry on the blockchain. And the registry are also assigned by the council, and the council is a decentralized organization, right? So in this way, it's kind of like less centralized or somehow decentralized identity. But this is just the very basic identity. There are also blockchains focusing on the identity itself. For example, Latentree and Qt, they are the Polkadot ecosystem blockchains, and they have more sophisticated identity management. For example, you can maybe, I don't know the detail, but maybe you can verify your ID or some other stuff on their blockchain.
Fantastic. Yeah, that's amazing. We have a couple of questions around kind of storage on Polkadot. So how much data can you store on the blockchain? For example, can I put several gigabytes of data on the blockchain? And also Loakesh has asked, how can you communicate from the chain to other servers, such as say file storages, databases, etc.?
Okay, got it. I think this is a really good question. So now the largest substrate-based blockchain is Kusama, because Kusama launched around 1 year earlier than Polkadot, and it has I think it's already like more than 1 year old. I think it already have 8 million blocks, but to my knowledge, the entire Kusama storage, which is just the state of the blockchain, is just around 200 megabytes. So it's not super large. But as a comparison, Ethereum has a state of around 9 gigabytes. And I don't think Substrate cannot handle larger database than Ethereum. So I cannot say the storage size is unlimited, but I think it's easy to store some data as large as Ethereum, like around 10 gigabytes in the current state. But this is the state. For the blockchain itself, there are also the blockchain history and the historical state. If you check Kusama historical state and blockchain, it's around 200 gigabytes. It's already very large because it has a faster block speed compared with Ethereum. And for Ethereum, I think if you synchronize the archive node, it will take around 1.6 terabytes, I think. So maybe after 2 or 3 years, Kusama will have a larger database than Ethereum. Who knows? Yeah, so that is about the size of the database. But you also raised a very good point. That is about the performance and how we can store a large amount of data with Substrate. And I think maybe not all the people know that there is something in the Substrate code base and it's not stable yet, but you can check it out. You can search storage chain. And it's just a few where is it? Storage. Maybe I found the wrong
When you first
name.
typed it in, you mistyped storage when you typed in storage chain.
Yeah, let's have a try. Yeah. Here it is. There's a tracking issue called the storage chains. So it basically allow you to send some transaction, very large transaction on the blockchain. And there are a few things offered by storage chain. If you enable storage chains, it will publish all the transaction and all the, all the data on the blockchain to the IPFS network. So it means that maybe you put a file on in a transaction and send it to the blockchain, and then this file will be available on IPFS. And just sending some transaction and make it available on IPFS is not interesting enough. And another thing I think is really interesting is that you can reference some storage. If you send a large transaction on the blockchain, it become a part of the blockchain itself, right? But it's not a part. It may not be a part of the blockchain storage. The state, because the size of the state cannot grow. Well, I don't think it's a good idea to grow it as large as possible, right? So on storage chain, you in the runtime code, you can reference some historical data stored on the blockchain, and it may not be a part of the storage, but you can still reference that and read the data from the transactions, maybe some very large size transaction in the block history. And I think this is a game changer. A very similar storage chain is called Rweave. Unlike Filecoin store the files off the off-chain, but Rweave store the files on the blockchain. So all the files you publish to the block to the chain become a part of the blockchain. And but Rweave only offer the storage, and on Substrate you can store some file on the blockchain. And at the same time, you can read the file and use the data. And I think this is really different, and it can enable a lot of potential new use cases on the blockchain. So as you can see, this is still a tracking issue. It's not fully finished yet, but I see a lot of potential of this new feature.
Fantastic. And there's been so many questions today, but I think we'll end on this last one from Michael, because I don't want to take up too much of your day. But Michael just asked, how can he access the Substrate technical group that you showed on the presentation?
The Substrate technical, right? I can share a link of the chat. So the
yeah.
element chat room. Yeah, but you can also, I have already shared the entire slide, so you can also just click that.
Exactly.
And yeah, also it's we're very welcome anyone to join our own Telegram group. Is the Phala developer. And you don't really need to talk about Phala network, like Polkadot, any Web3 related stuff or Substrate related stuff is also welcome to discuss on our group.
Fantastic. I'm sure people will be joining that. If you could post that link in the chat as well, that would be amazing. But yeah, thank you very much again for the presentation and for answering all those questions. I know there's a few questions we couldn't quite get to today, but for anyone that still has questions about Polkadot or the kind of wider parachain ecosystem, we actually have an event next week where we're going to have speakers from a few of the different Polkadot parachains, including Phala, Akala, Moonbeam, and Astar, which is previously called Plasm. But I think Danny's just going to pop a link in the chat for people to sign up to that. So it'll be the exact same time as this week. So feel free to come along and ask even more questions. But once again, thank you very much, Hang, and thanks everyone for coming along today. It's a fantastic session.